All right, today is October the 20th, 2015, and we're watching the tropical Pacific wide-angle map. This is an infrared map, and we're watching Hurricane Olaf right here. And this system is moving to the west-northwest at about 10 miles per hour, according to the National Hurricane Center. This storm has 150 mile per hour winds, so it's getting close to being a Category 5 storm. And it's moving along. It's got an eyewall, well defined, and we don't see much in the way of a blast pattern. Actually, on the last sequence of this loop, we do see a little bit of what looks like a blast pattern on the last frame, but it's very minor. So they're just allowing this thing to do its thing. They're allowing the storm to do its thing. Right now, at least for now, we're not seeing a major blast pattern signature on that. So let's go look at the same view in the water vapor loop. And there it is. Very little evidence of a blast pattern. Here we see a shock wave, a ring right here, a water vapor ring. So at an earlier time today or overnight, they may have hit this storm, but it's maintaining about 150 mile per hour winds, and we'll keep an eye on that. It is forecast to turn tomorrow up towards Hawaii, so we'll keep an eye on that. Let's go look at some of these other maps. Here is the water vapor loop for the Northeast Pacific. And right now in Southern California, right here, we're getting offshore winds. We have this upper level low that is still hanging around California. But what's happening here is that we're seeing a division built in with a radar is cutting just like a knife through this moisture field right here. And that will separate this jet stream flow from this moisture field to the right. So that's what's happening right now, and that is generating an offshore flow. And we can see that actually right here on the water vapor loop. We can see this area being pushed out to sea right here. That area, I don't know if you can see that on camera. But that is what's happening. We can actually see an area of tan that is moving away from the coastline. So they are starting to set up high pressure over the Great Basin, which is right around this area here, and that will generate offshore Santa Ana winds. Okay, let's look at this area right here. Let's look at the infrared loop here, and we can see how dry California is. It's actually at the end of this loop, it's purple down here, which indicates very dry weather. Now this morning we had about 34% humidity, and last night we had 74% relative humidity. So things have dried out quite a bit. The barometric pressure has dropped. It's around 29.97 where we live, and in the foothills. And so they are drying things out, and that is because of this high pressure that is being installed right here. And that will serve to block, it will divide these two moisture fields, and also, well, we've got this moisture field here feeding into this low pressure right here, which has been hanging around for days. We'll just have to watch what happens, but it looks like they are separating. They've got a separation right here that's being developed, and by today or tomorrow, we'll get a better idea of what's happening. And we have a whole new moisture flow here. It's going right into the jet stream and down right into California. So they are starting to divide this right here, and we'll keep an eye on that. We've got this storm right up here that has a HARP transmitter on it. We can see that this core has weakened. It doesn't look as organized. We've got the HARP transmitter right here with the hot air. And if we go look at the pressure analysis map, the surface pressure analysis map, they're showing this storm here, 972 millibar, but they're showing the warm front up here when in fact it's actually down here. That's where all the hot air is on the water vapor loop. But anyhow, then we got this cold front here and very strong high pressure right here to block that from the west coast, which is right over here. So we'll keep an eye on that. And I got another high right out here that's going to move into position. All right. Okay, so let's go back and take a look at some of these other maps. Here is the hurricane information for Olaf, Hurricane Olaf. Maximum sustained winds, 150 miles per hour. And we see that Olaf is moving west-northwest at 10 miles per hour and has a core pressure of 938 millibars. So that's a strong storm, 27.7 inches on the barometer. So that's a powerhouse storm. Let's go back and look at the map, because we have Tropical Depression 20E. This is the 20th tropical depression in the East Pacific this season. That system has 35 mile per hour winds, and it's moving west at 2 miles per hour. So we'll keep an eye on that. This will probably become a hurricane in the next day or so. So we'll keep an eye on that. All right, here is this is the geostationary image, satellite image, and you can see what's happening here on the west coast. We've got that mid and upper level low that's still spinning, and there is a division being set up here. They're cutting through this moisture field with a radar that will divide this moisture field from that, and we'll keep an eye on that and see what develops. Meantime, we're getting moderate offshore Santa Ana winds right now in the LA area, some of the foothill areas. Okay, we can see a very dry area where that high pressure here is installed right here, and that will run this front up and over, and all that moisture is dropping right back down into California. So the way this is set up right now is that we may get some rain in the future. We've got a situation where the jet stream is going to run a lot of this moisture right down into California, but remains to be seen if we get steady rain, saturating rain, that is going to do any good for the high Sierra snowpack situation. All right, here is this is the water vapor loop for the western U.S. We can get a better view of what's actually happening right now. We can see that this is being heated up and creating a fence, like an electronic fence, that is going to separate this field from that. And this is the jet stream right here. So they are interrupting the jet stream. All right. And in the infrared loop, we can't see as much detail, but we do see that there is a lot of moisture over here, over the southwest, over the Four Corner states. And the jet stream is right here. So we'll keep an eye on this. California looks pretty dry towards the end of this loop. All right, so that. Here is the pressure maps. We have sea level pressure. We've got that low right here, and that high, and the storm up here. Let's take a look. That's at sea level. Let's go ahead and look at, now they have a high indicated here. This is where they're going to install that high pressure. It's starting to show up here. Let's go look at the 500 millibar. That low is still very strong. It's all around the entire area here, this region. We got that high here. It's going to run this right over the top and down. And we have the 300 millibar, which looks pretty similar. Got that low right there. And that is still in place, still spinning. That's been there for a few days now. Okay, we'll have to wait and see what happens with this low. If there's They're trying to set up high pressure here. We'll see what happens. All right, so in the meantime, we will monitor that hurricane, and we will go ahead and do an update if needed later on. All right, that's it.